All right, this lesson is on solving one-step equations involving decimals. So we're going to solve these equations using inverse operations just like you've done in the previous unit. Remember, an inverse operation means the opposite operation. So the opposite of add is subtract. The opposite of multiply is divide. So take a look at this equation here. Remember, we call it an equation because it has an equal sign. So whenever you see an equal sign, that's what makes it an equation. So we're trying to solve for the unknown, the variable, the m in this case. And you ask yourself, what is being done to the m here on the left-hand side of the equation? Well, we are adding $45.20 to it. So that's what we want to do the inverse of, or the opposite of. So the opposite of add is subtract. And so we would subtract $45.20 from each side of the equation. And so over here on the left-hand side, we get a 0 because a 45.20 and a minus 45.20 cancel each other out, add to 0, and then you just have m on the left-hand side of the equation. And then so here, $69.95 minus $45.20 is $24.75. And it's important that you check these answers. You can always take this answer here for m and replace or substitute it back into the original equation. And just to make sure that it works, does $45.20 plus $24.75, does that really equal $69.95? And yes, you could check it one of two ways, on a calculator or by hand, and you can see that in fact it does work. Remember, when we are adding or subtracting decimals, it's important to line up the decimal point. All right, so we kind of talked a little bit already about solving equations using the inverse or opposite operations to get the variable all alone on one side of the equation. So take a look at this equation here. Some number minus 6.2 is equal to 9.5. So I look at it what is with the variable, the unknown here. In this case, it's on the left-hand side of the equation, and it is with this minus 6.2. Well, that's what I need to do the opposite of. So what is ever with the variable, that's what you're doing the opposite of to get that variable by itself. So in this case, 6.2 is being subtracted from k. Okay, well, to undo that, the opposite of subtraction is addition. So we need to add the 6.2 to both sides. That gets k, or the variable, all by itself on the left-hand side. You can see that if I combine negative 6.2 and positive 6.2, you get 0. And k plus 0 is just k. And then now go ahead and add 9.5 and 6.2, and we get that k is equal to 15.7. So remember, when we're adding or subtracting decimals, it's important to line up the decimals so you have the place values aligned. So here's the 10th, one place after the decimal, so you add 5 plus 2 is 7. Bring down the decimal, and then yes, 9 and 6 is 15. Now, we can always check to make sure our answer is right. That's the nice thing about solving equations. You can always check and verify and guarantee that your answer is correct by replacing it or substituting it. That's the word we use in math to mean replace. Substitute your answer back into the original equation. All right, so we're going to substitute 15.7. That means replace the k with 15.7 because k is 15.7, right? Or we think it is. All right, so now we're going to go ahead and subtract 15.7 minus 6.2. And with this little question mark over the equal sign, it's like I'm asking myself, does 15.7 minus 6.2, does that really equal 9.5? And then if you have to check it with a calculator, you can. And in fact, it is 9.5. So 9.5 equals 9.5, and this, I get a true statement like this, because 9.5 is equal to 9.5, then we know that our answer worked. Okay, so here's another example of a one-step equation involving a decimal. Here we're going to solve this problem, and originally it's involving multiplication, correct? Because we ask ourselves, what is being done to the variable, in this case k? Well, k is multiplied by 6. Remember, when we write the number right next to the variable like that, we don't have to put the time symbol or the little dot. When we write them right next to each other, it does mean multiply. It means 6 multiplied by some number is equal to 7.2. Okay, so now we have to ask ourselves, well, if we want to get that variable by itself, we need to do the opposite. So what is the opposite of multiply? All right, and the opposite of multiply is to divide. So we're going to divide both sides by 6. That's the nice thing about solving these equations. You're allowed to do absolutely anything you want to get the variable by itself as long as you do it to both sides. Now, some things aren't going to help you get the variable by itself. For example, I could choose to add 1 to both sides of these equations, but that wouldn't help me get 6 by itself. Excuse me, the k or the variable by itself. So when I take 7.2 and divide it by 6, we get that the answer is 1.2 as a decimal. So if you need to review how to do this by hand, you can go back to the previous lessons and look at the videos there. All right, we can check this easy enough, just like we did before, by substituting the 1.2 for k back in the original equation. That means replace it. So when I replace it, notice how I put these parentheses here? That's just to keep this organized. I don't want to write 61.2. That might look like 61.2 or something like that. That's not what we want. We want to say 6 multiplied by 1.2. So when I write them in parentheses here and I write them next to each other like that, again, that means multiply. So when I multiply 6 and 1.2, I do in fact get 7.2. So this is a true statement. So then we know that our answer is correct. Let's do an example that involves division. All right, so here we have an equation where we have some unknown number being divided by 7 equals 0.6. And so how are we going to solve that equation? Well, we ask ourselves, what is being done to the variable and how do I undo it? So when I write this fraction bar here, that does mean division. So it means some number divided by 7. So m is being divided by 7. I need to undo that. Okay, so in this case, we're going to multiply both sides by 7. Right? The opposite of divide is multiply. And so here I'm showing, when I'm writing the red dot here, I'm showing that I'm multiplying both sides by 7. That isolates the variable on the left-hand side because a 7 being divided by another 7 is just 1. And 1 times some number is just the sum number, as in this case m. All right, so 0.6 times 7 is 4.2. So remember, when we're multiplying with decimals, right, it's not necessary to line up the decimals. You just line up the numbers, multiply how you normally would, and then at the end is when you decide where to put the decimal place. So in this case, notice that I only have one number to the right of the decimal place, which is the 6. So when I multiplied 6 and 7 here, I would have got 42. But then because I have one place after the decimal here, I move my decimal back 1. All right, so we can check, as always, by replacing the variable with what we think the answer is, in this case, 4.2. So we substitute 4.2 into the equation. 4.2 divided by 7, is that really equal to 0.6? And if you got on a calculator and checked it, you would find out that yes, it is equal to 0.6. So we know that 4.2 is the solution. All right, so here's our last type of problem that we're going to investigate in this course. All right, so solve the equation here and check your answer. We have some number being added to 3.7, and that equals 8.6. So find that number. So you ask yourself, what is being done to the variable? Well, we're adding 3.7 to it, so we need to undo that by subtracting 3.7 then from both sides. All right, so we subtract 3.7 from both sides of the equation. That's how we get the variable all by itself. And then 8.6 minus 3.7 is 4.9. And now I'm going to check. Is 4.9 plus 3.7, is that really equal to 8.6? Then you could add these by hand or with a calculator and find out that yes, it does equal 8.6. So we get a true statement. So then we know that our answer is correct. And so take a moment to pause the video and work out these 4 examples. All right, let's take a look at number 1. So what is being done to the variable is that I am adding 2.2. So to undo that, I'm going to subtract 2.2. You should have subtract 2.2 from both sides of the equation. I keep the decimal lined up when I'm subtracting by hand. And we get that m is equal to 8.5 minus 2.2 is 6.3. I just subtracted 5 minus 2, 8 minus 2. Didn't have to borrow or carry. All right, so number 2. You should have said, well, what's the opposite of subtract? I see a minus sign and right away you do plus. Do the opposite of what you see being done to the variable. To both sides of the equation to keep the equation balanced. And then this cancels out. And we get that m is equal to 9.2 in this case. All right, so problem 3. 4m equals 14.6. So remember, that means multiply. 4 multiplied by some unknown number is equal to 14.6. Right, so we do undo multiply by doing divide. So in this case, I'm going to divide both sides by 4. The 4's cancel, leaving a 1 over here. 1 times m is just m. So we have the m all by itself, just like we want. And now we go ahead and do this division problem. So 14.6 divided by 4 is equal to 3.65. All right, and then you could always check. Does 4 multiplied by 3.65, does that really equal 14.6? And if you check that on a calculator, yes, it does. All right, so the last one. M divided by 2 is equal to 4.2. So what number can I divide by 2 to get 4.2? All right, so what's being done to the variable? Well, it's being divided by 2. So I need to do the opposite of divide, which is to multiply. So we're going to multiply this side by 2. I'm going to multiply the right-hand side by 2. This cancels, and we get that m is equal to 4.2 times 2, which is 8.4. So if you didn't get those answers, make sure you go back and look at the previous slides and see where you went wrong. And now we're going to apply this to some word problems. So the area of a rectangle is its length times width. And the area, remember when we refer to area, we're talking about the space inside of something on a two-dimensional figure like this. So a lot of times you hear about how big a house is. They talk about its area. They talk about how big it is in square feet, how much room is inside it. All right, when we have something that is a rectangle like this, we just multiply the two side lengths together, and that's the space that's inside of it. All right, so consider this problem. The area of Emily's floor is 33.75 meters squared. So you notice that little 2 being raised as a power? We read that as square meters. So whenever we have an area, our unit is always going to be something squared, right? Could be feet squared, could be meters squared, could be inches squared. right? And the reason why that is because we can think of the space inside of an object as being covered with little squares, and how big are each of those squares is what we're trying to say. And how many are there, right? So that's why we call it it's a square area. So in this case, if the length is 4.5 meters, right? So let's say this is 4.5 meters here. Then we want to know how big the width is. So don't look at the squares I drew in there. It might not be accurate. But we know that if we multiply these two numbers together, we should get this answer, 33.75. So I'm going to write out this equation here. The area is equal to the length times the width. And then now I'm going to substitute. Remember that word substitute we talked about earlier. It means replace the letters or the words in this equation here with what we know they are from the problem. And it tells us the area is 33.75. So in here, I replace area with 33.75. In general, the area of a rectangle is length times width, as we saw in the previous slide, is equal to the length. Okay, the length is, so I'm looking for the length, there it is, 4.5. So that's why we replace the length with 4.5. Then that's being multiplied by W. So now look, we have an equation just like we were solving in the previous slide. It doesn't matter that the variable's on the right-hand side of the equation. We could flip it around if we really wanted to and make it on the left. But we can solve it directly here. And so what's being done to W? Well, it's being multiplied by 4.5, this whole decimal here. So I'm going to undo that with division, right? We undo multiply by divide. So I'm going to divide both sides by the 4.5. And I take 33.75 and I divide it by 4.5. Remember that order matters. And then we get the variable all by itself. These cancel. And 33.75 divided by 4.5 is 7.5. So what is 7.5 what? All right, so all of our measurements here were in meters or square meters. So the width here is 7.5 meters. So that's why I put the units with it here when I write it out. You could kind of check, does that make sense? Like if I had a rectangle, if this was 4.5 and this was 7.5, then I'd probably have 33, almost 34 little single squares in there. And that seems right, right? When I multiply those two numbers, that I get 33.75. Now taking that same problem, suppose the carpet costs $23 per square meter. What would be the total cost to carpet the floor? So for every little square meter that you have to carpet, it's going to cost you $23. So what do we need to know? Well, we want to find the total cost. So what we need to do is take the area that we're carpeting and multiply it by the cost of the carpet per square meter. Okay, so from the previous problem, right, we know that the area was 33.75. That's what it told us in the problem. And the cost of the carpet is $23 for every single one of those square meters. So I'm just going to multiply those two together, right, to get the total cost. So it's like saying each one of these costs 23, so how much does 33.75 cost? Well, that's a multiplication problem. So we get 776.25. So remember what this problem is about. Dollars, the cost, how much something cost. And the cost of something is in dollars in the United States. So we write that it costs $776.25. Let's try another one. The area of Yvonne's bedroom is 181.25 square feet. So that's what we mean when you see that little 2 raised to something. It means square feet. If the length is 12.5 feet, what is the width? All right, so if I were to draw out the little problem with a picture, I love drawing pictures whenever I can. It's a good problem-solving technique. The space inside here, they're saying, is 181 14.25. That's the space inside that rectangle. Right, and they're saying the length, one of these sides is 12.5 feet. They want to know this. How big is that, the width? All right, so I pull out my little formula for the area of a rectangle. And the area of a rectangle is equal to the length, that's this 12.5, times the width. We don't know. But we're going to go ahead and write our equation and substitute or replace the values into our equation in the appropriate spot. All right, so the area is what's 181.25, so I replace it where the A is the area. The length is 12.5, and that's being multiplied by W. So we're going to solve for the W, the width. So it's a nice thing when we write an equation. As long as we know everything except for one variable, we can always solve for it. All right, so over here now we have the variable. We do have it on the right-hand side of the equation, but that's okay. That doesn't change anything. You still ask yourself, what is being done to the variable and how do I undo that? So in this case, we are multiplying the unknown, the W, by 12.5. So we need to divide both sides by 12.5 to get the W, or the variable, by itself. So I'm going to go ahead and divide both sides by the 12.5, and we get that the width is 14.5. All right, so we're saying that if I take 12.5 and I multiply it by 14.5, I should get 181.25. And in fact, you do. All right, so we say that the width of Yvonne's bedroom is 14.5. Now, going off of this same problem, we could say, how much does it cost to carpet the floor if it costs $4 per square foot? So the first thing we need to know, what do I need to know to solve this problem? Well, we need to know the cost for every single square foot, and we have that answer here. And then we need to know how big that bedroom is. How many square feet is that bedroom? Okay, so from the previous slide, we saw that the square feet of the bedroom was 181.25 square feet. Each and every one of those square feet cost $4. So this is a multiplication problem. Right? To find the total cost, I need to multiply the area times the cost of the carpet per square foot. So when I take 181.25 and multiply it by 4, we get 725. And remember, we're asked to find the cost of something here. So that unit then would be in dollars. It cost $725 to carpet that room.